All right, so we see y equals 1/2 to the x power graphed at the right. First of all, let's describe what happens to y as x gets bigger and bigger. For example, what is y when x equals 20, when x equals 100, when x equals 1,000? So we can try that. If you wanted to actually calculate those, okay, you would have y equals 1/2 raised to the 20th power. So then use your calculator, all right, and you're going to get a number that looks like this. It's going to be like 9.53674 e to the negative 7. Guys, that means it's a really, really, really small number. If you look at your graph, if we were to go way out here, further on the x-axis, we're going to have values that have our outputs that are really close to the x-axis, which means they're really close to 0. So the bigger our x value gets, so the bigger the x value, the closer the y value is to 0. Or you could say the smaller the y value is. So then the next question says, does the graph of 1/2 to the x power have an x-intercept? So in other words, is there some way that I can get my x value to be, my y value to be 0? Is there some power of 1/2 that would give me a y value of 0? Now, there was a problem you did on your homework a while back that had the situation where I think it said something like the teacher told you could walk half the distance to the door. And you could continue to cut that distance in half. And the question was, would you ever actually be able to leave the room? And the answer to that is no, because there's always going to be something that you can cut in half. Okay, half of a really small number is just a smaller number. So when we're looking at our graph, we're going to continue to get closer and closer and closer to the x-axis, but we'll never actually reach it. So we would say that there is not going to be an x-intercept. And here's why. Because there's no way that we can get a solution to that. Okay, there's no way I can get an output of 0 using the equation that I have.